Hello, viewers. Welcome to another episode of Let's Talk Science. This episode is supported by Science for Society, Indian Humanists, and Babu Gogineni Humanists and Rationalists Arena Facebook group. So today we have a very special guest who wants to share her experiences and opinions on a lot of things related to science, not just astronomy and space science, but also scientific temperament, culture of science, gender equality in science, and a lot more. So before introducing her, let me first welcome Mr. Arjun Nidigallu, who is also joining me in the panel from Sydney. Welcome, Arjun Garu.
Thank you. It's my pleasure to be here. Thank you, Prasada.
And also our master, Teja Begari, youngest amateur astronomer from Busy Group. Welcome, Teja.
Thank you, sir. It's a great pleasure.
And also, it's my pleasure to have Jyothsna Palwai Garu, a co-founder of Science for Society. She is joining from Chicago, though it is, I think, late for her. Thank you for joining, Jyothsna Garu. Welcome to the episode.
Thank you, Prasad Garu, and pleasure is mine to have participate in this session with all the interesting panelists.
Yeah, again, it's our pleasure, Andy, again. So, yeah, now our special guest, Dr. Prajval Shastri. She is a former astrophysicist from Indian Institute of Astrophysics, and her area of specialty is phenomenology of active galaxies driven by supermassive black holes using multi-wavelength observations ranging from radio to X-ray wavelength. So let's get back to her and welcome her into this episode of Let's Talk Science. Welcome, Prajval Shastri.
Very happy to be here.
Yeah, it's an honor for us to have you here in I think the 4th episode of Let's Talk Science. So yeah, I'll hand it over to Jyothsna Garu to start interacting with Prajval.
Yeah, I think there is more to Dr. Prajval Shastri. I think she definitely needs a good introduction to our audience. So, audience, Prajval Shastri is an astrophysicist for nearly 4 decades. She investigates, as Prasad Garu said, she investigates the physics of giant black holes that are found in the centers of distant galaxies using telescopes at multiple frequencies based on Earth as well as in space. She got her PhD from the Tata Institute of Fundamental Research, and after postdoctoral research positions at UT Austin, University of California at Berkeley, and the Harvard-Smithsonian Center for Astrophysics, she was a faculty of the Indian Institute of Astrophysics, Bangalore for 23 years. She has been a Fulbright Fellow at Stanford University and is currently Emeritus Scientist at the Raman Research Institute and also the Adjunct Professor at the International Center for Radio Astronomy Research, Australia. She's extremely passionate about science outreach. She believes that the cultivation of scientific thinking is for everyone, and she uses astrophysics as a vehicle to engage lay audiences of all ages with these questions and works for the people science movement towards this goal. She's also deeply concerned about the inequities in the science and attempts to bring an intersectional lens to the endeavors to mitigate them. She is the founder and past chair of the Gender in Physics Working Group of the Indian Physics Association and the member of Working Group for Gender Equity of the Astronomical Society of India. She is Vice Chair Designate of the Women in Physics Working Group of the International Union of Pure and Applied Physics, and she's also on the Executive Committee for the International Year of Basic Sciences for the Sustainable Development. In addition to her research publications and popular articles on astrophysics, her published works include writings on gender equity as well as science and society. It's a pleasure, Prajval, to have you on our show. And with that, let's get started with an engaging discussion with all our panelists today.
Sure.
Thank you,
So-
Jyothsna girl. That's
Very
a
much.
really good introduction. Yeah, go ahead,
Yes.
Prajwal.
Yes. So, I mean, we can start with some basic questions. What I was thinking was, I mean, I think we all need a basic understanding of how this universe began and how it evolved, right? This basic understanding is a must for everyone. And the dangers of lack of this basic understanding is multifold, and it is a breeding bed for many disbeliefs, superstitions, and in general, this question has intrigued human forever, right? And you, from your childhood, have childhood and through over the years of your career and with your work, you studied the sun, stars, planets, galaxies, their evolution, and the most important tools to decode this universe, right? So for you, it's very easy to understand and deduce meaningful conclusions about the evolution of universe and our place in this universe. But how do you explain it to general public to whom topics like Big Bang, general relativity, black holes are a distant reality, or so why is it so difficult for the general public to grasp this concept that all the matter in universe came from nothing, and how actually would you explain the term nothing?
Oh, well, so some of these questions that you're asking, they're not really, shall we say, at the core of my own expertise. But on the other hand, what you say is also right, that this sort of idea of our place in the universe and what the universe is like and how it evolves, that is something that all of us, regardless of our specialty, need to grapple with. Because it's a very strong, not just a scientific thing, but it's also a very strong cultural thing as
Yeah.
to how we understand about ourselves. And in that sense, I think people who have been on this series earlier have also talked about how our thinking has evolved from being a very inward looking, sort of what people call anthropocentric kind of view of the universe. And then gradually we realized that first the Earth was not special, then the solar system was not special, and then the Milky Way itself is not special. That is both outward looking in terms of realizing how big the universe is, unfathomably big, and therefore how insignificant we are. But also, it sends us back inwards to think about how precious the Earth is as a planet and how we need to collectively preserve that heritage in a sort of collective thinking fashion, in a collaborative fashion, as a partnership between all peoples. You ask, why is it difficult for people to understand the origins and evolution of the universe? I would say it's difficult for anyone, including physicists, to get their heads around this idea. But yes, the fascinating thing, I think, is that the ideas from the theoretical predictions of how our universe might work match really well with the empirical evidence. And that has been a very, very exciting phase over the last few decades, especially the evidence that favored the idea of what is called the Big Bang, that the universe originated in sort of quote unquote singularity, which just means we don't quite understand what it is, but we do know that it has since then expanded. At some point, until some point, it was a very, very hot universe where everything was ionized, and so it was like this plasma, and then how, as it expanded, it cooled, and at some stage, because of the fluctuations in the density, it led to certain structures forming. So cool gas can eventually compress because of its own gravity and compress into structures that we know today, whether it's galaxies or stars and galaxies and so on. This is how we think of the universe, and the evidence that, for example, satellites started with the early microwave satellites itself, like COBE and so on, and now then we had WMAP and then Planck, and the evidence from data from these satellites is very, very consistent with this picture that we have. Some of you may be old enough to remember how the data from these satellites showed a perfect black body spectrum, the most perfect black body spectrum, which was really, really fascinating for all of us. And it's, for me, it's not just that we have a certain understanding of how the universe formed and how it then expanded, and then how structures formed and galaxies formed and stars formed. But it is also, at a very deep level, fascinating that what very, very independent methodologies lead to all come together like a jigsaw puzzle. So the theoretical predictions from microwave telescopes, which are very, very different thing from the other telescopes and so on. So that is also very fascinating. The idea that the Milky Way is just an ordinary galaxy, it was an idea which came about fairly early, but in the 90s, when the Hubble Space Telescope director actually decided to use directorial discretionary time in order to just stare at an utterly nondescript piece of sky, which was about a third of the size of the moon in the sky. And how that long exposure of a few days showed us that there were 3,000 galaxies just in that third of the size of the moon patch of sky. And of course, then it meant that every patch of sky would have that many galaxies. And then later on, Hubble Space Telescope, with its more advanced camera, looked at an even smaller patch and showed 10,000 galaxies, and so on and so forth. You know, that sort of story. That is a story in itself. I mean, it's even though we knew that there were billions of galaxies in the universe, just looking at that small patch of sky that the Hubble revealed to us was like one of those goosebump moments. So yeah, it's I think in all of this, what really scientific thinking teaches us is to firstly, of course, base our understanding on the evidence. Be willing to change our understanding when the evidence contradicts our earlier understanding, but also being comfortable with uncertainty. Understanding what is scientific uncertainty, being comfortable with that, and also being comfortable with not knowing. So we know that there are certain things that we don't know. So for instance, we cannot, as of now, penetrate into the moment of the Big Bang. The earliest data we have is from the microwave background, which was sometime after the Big Bang. And it is possible that when the gravitational wave interferometric observatories go into space with this telescope LISA just being proposed, it is possible that that would give us some window into a slightly earlier time, but that's not clear. We don't know. And scientific thinking teaches us to grapple with and to be at ease with both what we know and what we don't know, and that sense of uncertainty. So that is something I think that all of us, regardless of whether we are scientists or not, all of us do need to grapple with. Which is, there's a lot of pushback on this. People will say, will rebut scientists' arguments based on the fact that, you don't know everything. So there's so many things you don't know. So, but yeah, so that's the whole thing that hopefully at some point all of humanity can share.
I think that's very brilliant. And one more thing I feel is that it also allows us to think how minuscule we are in the grand scale of this universe, right? And set our prejudices aside and enjoy this universe as is, and also the moment, right? We carry so much baggage that we think we are the highest in the ladder. Prasad Garude, you can take your next. You can take your turn, Andy. I'll join you in a bit.
Yep. Thank you, Jyothsna. It's a good question, and as Prajval explained it, I think not knowing everything or many things is what keeps us motivated and helps improve our curiosity, not just children but also youngsters and scientists, everyone. With the recent photograph that we it's not a normal photograph, but I think from the radio photography, right? The supermassive black hole at the center of our Milky Way galaxy. So day and day, it's very interesting to see a lot of things getting unveiled. And if you look at last 30 years, like 30 years back, we don't know if there are exoplanets, or like how many of there, or how far they are, and how big, or what composition they had. So now we have like hundreds of such exoplanets cataloged properly, and actively that number, we are getting a big number of revelations like that, like what is where and things like that. So certainly science doesn't know everything, or at least it has to know a lot more at this time, but that is the only way. The only way is science and scientific method to help understand how we came and where we are, and how the whole universe happened. So I have a question, Prajval, uh, about the lack of gender diversity, especially in physics. Say, if you take as a subject, as the primary field in the actual sciences. So lot of women we see drop out from, I won't say from the studies as well, but from the sciences, like physical science or chemistry. um, um, so what could be the reason there, and what needs to be done to help maintain that diversity in science?
Well, that's a very big question, but you're right that there is a lack of diversity in the sciences globally, and physics is a discipline which is among the worst in terms of the diversity index. And that is also a global thing. I can speak about the situation in India, and there is, of course, the question of what are the reasons for this, because that will determine what we do to mitigate the gender gap. So one thing I will say is that there has been a tendency to relegate the responsibility to so-called outside society and say that there is gender inequity in outside society, and that is what gets reflected within the sciences. The problem with that approach, one problem, of course, is that it is actually not looking at the evidence. So if it was perhaps a reasonable hypothesis to put forward 40 years ago, when there wasn't enough evidence, the question wasn't studied. But now we have a lot of data, and it is fairly clear that there are barriers within the profession, which are what prevent a completely level playing field for all genders. So if you look at the example of India, for instance, over the last several decades, there is recognition that there is a lack of diversity. The government recognized it many years ago and put in a lot of money. This was right in the mid 2005 or so. There was a lot of investment by the government into schemes and so on, which might mitigate the gender gap. However, within the scientific establishment, there wasn't an acknowledgement that there is a problem. Of course, nobody can deny the numbers. So there is actually a gender gap, and nobody can deny that. But there was not an acknowledgement that the barriers may lie within the profession. There have been studies. For example, there's a study by Kumar, which was published in 2001, which tracked men and women scientists within science institutions. She sampled a few science institutions, and she found that for the same, there was no productivity deficit between men and women scientists who were employed within these institutions as measured by their scholarly publications, but there was a distinct difference in the grades at which men and women were for the same productivity. There was also an age gap in that women scientists with the same productivity had to wait longer to get into the higher echelons of the institution. So this was a very, very early study, 2001, but it was done by a sociologist, and even I, who had some interest even at that time in this question, was not aware of this study. So, it was not that this person went around giving talks in science institutions about this study, which is very, very strange. I mean, so it speaks to the fact that within science institutions, there is not an acknowledgement that there is a problem within. There is not even an acknowledgement that it's a sociological problem. And therefore, we need to talk to social scientists in order to understand why that problem is and how to mitigate it. Another example is that a lot of institutions and government and a lot of money is pumped into programs which encourage girls to come into science. Now, it may be true in certain cultures. For example, I have heard that in the US, for example, it's a very serious problem that girls don't choose science subject. There is evidence for it. But that evidence, that is not the case in India. At least it wasn't the case until a few years ago. And there's very strong evidence for that. For example, if you look at the high school 12th grade exam results, women outperform men. The college enrollment in science is not low. And if you look at, there are these very prestigious national competition-based fellowships for science, for higher education in science that the government offers. They're called the Inspire Fellowships, which is an anagram of something. And they are won by, for all of science, more than 50% by girls, by women. And in physics, it's equal equal numbers of girls and boys win these fellowships, which mean, I mean, that, and the fellowship is not a trivial thing. You have to study for an exam, you have to give the exam. So it does not at all tell us that there is a lack of interest in science among girls. So to me, it doesn't make sense to pump money into programs which encourage girls to come into science. Girls are fine, they are coming into science. The question is, you have to fix the system and make sure that there are no barriers to the ones who want to come in, and also to the ones who do come in. So those barriers need to be fixed. Like Kumar showed, at the high level, there are barriers. For the same productivity, women are kept behind. And the other data that I talked about shows that girls are as interested in science. There's no problem at all. On the other hand, there was a small survey done of 4 high schools in Dehradun, which was published a couple of years ago, which showed that girls were as interested in science as boys. There was not that huge deficit, but more boys than girls thought that girls were not competent in science. That girls did not pick science, which is not true, and that they did not pick science because they thought it was a difficult subject. So neither of these is true, but that is what more boys than girls thought. So it is very clear that there is something in our education and in our society which is educating boys to think that girls are incompetent in science. And of course, then these boys will go on to become, tertiary education students, and then into the science and into the profession, and they will hire people, and they will carry this bias all along. And the bias manifests in many ways. I mean, for example, in India, many very, very elite institutions, and by the way, the gender gap gets worse as you go up the eliteness ladder. So the institutions of excellence have a worse gender ratio than so-called I don't want to say not excellent. I mean, there is a lot of excellent work that goes on in universities and in colleges, but they are seen as a second rung institution compared to, say, my own institution, like the Indian Institute of Astrophysics or TIFR, where I did my PhD. But in these elite institutions, the gender gap gets worse. So there are, for example, these unwritten rules that will disqualify a woman from being hired if she has a spouse who's employed in the same institute. And this cannot be a written rule, obviously, because it's blatantly discriminatory. But it is an unwritten rule, and I know women even now, as in not 10 years ago, but now, who are told, no, you don't bother applying here because your husband already has a job. And there was a survey actually done by the Indian Academy of Sciences a few years ago, and that was a very good survey because it actually was a collaboration between scientists and social scientists. And so the social scientists got women not just within science institutions, but also women with PhDs who didn't have jobs. They managed to catch hold of such people and interview them as well. And it became clear that they didn't have jobs because they didn't get jobs. It was not because family responsibilities prevented them from doing science. So yeah, it's a very fraught problem, and the gender bias within science institutions needs to be addressed. There needs to be bias training, not just for men. I mean, regardless of gender, we are all gender biased. Because that's how we are raised. So all of us need to undergo gender bias education, inequity education, so that we can address the biases within our institutions. Sorry,
That's very
that's a
wonderful.
long answer.
That's very wonderful. And now just because you mentioned about the responsibilities, I think as a woman gender, it is the fact that women were expected, even if they are in good positions or into the science, like there is a lot of time demand from the women, especially, given the society where we are in. Um, was it a problem at any point of time in your career, where you had to put a lot more effort than comparatively than another person at the same level where you work, and how did you try to balance those, like not just, it need not be your own experience, but any of the examples you have seen. um, so how did you, or how did that person try to manage things, or um, what are your recommendations there?
Well, so it is of course true that society has discriminatory expectations based on gender. There's no question about it. But these expectations manifest in a whole bunch of different ways, and I would say what institutions, I would come back to the institutions, because uh, I would say that it was not the demand on my time that society put, which was the biggest barrier. It was more the discriminatory expectations within my institute. So women will tell you that it's a sort of damned if you do, damned if you don't situation. So, for instance, women who don't have children, or who are single, they get comments like it's not the normal thing, and sort of thing. Women who have children will get comments, if they have young children and they stay at work and do work, they will be told, you should go home and take care of your children, like it's somebody else's business. And if they say that they have a certain, because of some responsibility, they can't attend a meeting, say at after office hours, then they will be talked about as, oh, but she's not going to put in her everything into this because she has children to take care of. So it's like a damned if you do, damned if you don't situation, and that is the bigger problem, I would say. And there is a problem of demand on time also within institutions, because it's not about, now it's no longer about societal expectations, but it's about, for example, one way that institutions think they can address the inequity problem is to say that all committees should have women representation. Now, my point is, all committees should have women representation because it's the right thing to do, not because it's going to address gender inequity, because gender inequity is a much deeper problem. Of course, numbers and committees need to address that. But what happens in institutions with very, very few women is that as a result of this policy, they get put on a whole bunch of committees. Because there are only 2 or 3 women, they have to serve on all committees, so there is an undue burden on them. They are not, that is not acknowledged, that will not be taken into account when they come up for promotion or whatever. So that is the problem. And to rebut what you're asking, you would not ask this question of a man scientist, as to what was the, were there
Yeah.
extra,
we,
after all,
we did
folk
we did ask
origins.
we did ask our at least one or two previous hosts in the same series as well, but just that you are too vocal in this area again, like I have to bring that up.
Yeah, I know. No, I understand the question about inequity, but the thing is, yeah, I think the question about inequity should be asked of all
Yep.
scientists. And
Yep.
frankly, I don't know of a male colleague who has been asked, how do you manage, you have small children, how do you manage? I don't know anything like that, but every woman is asked that. So, so there are these expectations from colleagues and so on, regardless of what the, how the woman is actually managing her personal life. I mean, there may be so many things, it could be that her spouse shares equal responsibility with her, but the spouse will not be asked, how do you manage your children, So the expectations are very much systemic and they're very much institutional and structural. So yeah, that is what we need to address.
I think Arjun wants to add something here, and maybe after that, Jyothsna also can join. Maybe,
I was just thinking, Prasad Garu, there is some learning for us too here. And I think the better way to deal this is just have democratic families and democratic institutions.
that is the reason, Jyothsna Garu, we had to pull you again for this episode.
No.
If we talk about the diversity of women and the representation of that, look, at
without
least
having in
without
the
having
panel. Right. Yeah.
Good to see that. So Arjun wants to add something here.
Yeah, if I may, while we're on the topic. So it's a great point you bring up that you wouldn't necessarily ask a man about how you're coping with managing your kids and working at the same time. It's not something we do. You're absolutely right. But look, my question while we're on the topic is my first discovery of your work came through with that article in The Conversation on gender barriers in physics that you wrote. Brilliant article, by the way. I loved it. So my question really is, you talked about how we can have gender bias sessions, educational sessions to educate everyone on the topic. But from a cultural point of view, what needs to change in your view? And in particular, what do the silent majority, excuse me, what do the silent majority, mostly men at the moment, I suppose, need to do to bring about a change, right? That's really a pointed question, I know, but I was hoping you could use your experience to give us some guidance on this.
Yeah, so I think that gender inequity or any kind of inequity, because there are inequities on multiple dimensions in India for sure, whether it's caste or ableness, there are multiple, or sexual orientation. There's discrimination happening on multiple dimensions. So inequity is everybody's problem. And so
Yes.
everybody needs to pitch in. So that is the other ridiculous situation within the sciences, that if you have a scientific cohort that does not reflect the distribution in the population, there is clearly something wrong, and that needs to be addressed. But it is something wrong, period. So it needs to be addressed by everyone. So it shouldn't be up to the people discriminated against, to the marginalized, to raise the problem and talk about the problem and do something about the problem. It has to be everybody's responsibility. So that is a very important thing. And I mean, there is always a tendency. I mean, it's ridiculous. I was once in a meeting with several fairly high people people in fairly high positions of responsibility, and we were talking about just a scientific conference and how there needed to be gender diversity in the speakers and so on. And the one person says, "Oh, let's have a lady on the scientific organizing committee, and that lady can get more ladies as invited speakers." If you're a scientist in a certain field, everybody who works there. You don't need to be a lady to get the,
That's right.
So, it needs to be understood that equality is everyone's work. And everyone needs to pitch in, and it needs to be taken as a part of the mandate. So just as we put in time for the library committee, or the, in India, we even have garden committee and cafeteria committees. We need to have diversity committees into which everyone puts in time. It shouldn't be
100%.
the marginalized.
Yeah, thank you for that.
Yeah. One more question related to this, like representation or underrepresentation of women in science is one thing. The other thing is cultural challenges compared to men. In my opinion, I may be correct or not. It's very easy for men to be rationalistic and come out of the following certain traditions and which which people carry from different generations, but not so easy for women, as I feel it is, because they are expected to do some things even if it is not for them, for the family. So there is, I think, as people know a lot, like gain knowledge, uh, the in the process, like they will have a lot of conflicts, especially when people, women or people in science, like when they try to learn what, understand the universe around, like they'll uh, you know so there will be a lot of things that clash because of the traditions and the brainwashing that we were all subject to. um, so for, I think, for men, it's easy to actually come out of that and apply that rationality, or become more rational as the time goes. But is it so with the women as well? Because of the situation, not that they don't, they deny evidence, and they stick to beliefs more strongly, but because of the cultural pressures, if I can use that word. um, um, so how does it affect, like uh, what needs to be done at individual level or family level, or at the education teaching level, like to help women cope up with that, and um,
So I'm not sure. I mean, that's not an easy question for me to answer. I'm not, because I'm not familiar. I haven't looked at evidence which tells us that it is more difficult for women to, sort of be rational. I know it is more difficult for women because patriarchy is very strong, at least in Indian society, which plays a big role in, because of patriarchy, women don't have autonomy in their lives, less autonomy than the men do.
yeah.
I mean, there are. It's not like everybody has full autonomy, because we have a lot of societal systems in place which come in the way of that. For example, the caste system comes in the way of autonomy. Um, the idea that marriage, for example, I'm talking about larger society now, not just not the science cohort, but in larger society, marriages are still very much happening in a sort of non-autonomous way. And when people cross, say, religious lines or caste lines in order to love and get married, there is a huge amount of pushback from their sort of epsilon neighborhood, so to speak, from their own cohort, from their own communities. There is not that much support. And it is seen as a transgression when you cross caste lines or religious lines to get married. It's seen as a transgression. And typically, although both parties get affected, typically the women always get burdened or get a, sort of are at the receiving end more than the men. In terms of rationalist ideas, uh, again, there is a huge patriarchy there. For example, during eclipses, there is this whole thing of putting people in and all that, and women, especially pregnant women, are literally imprisoned within their homes, and they are the fear of God is put into them, saying something will happen to their child, etc. So it's, you can't say that. Uh, I wouldn't say that it's because they are more irrational than the men. There's the pressure on them is just huge, and lack of autonomy and all that. So it's a difficult one. What I would say, working in the people science movement as well, that their representation, again, just like in scientific institutions, there is not equal representation of men and women, and I think that people who advocate um, rational thinking and so on, also need to look inwards into their own ecosystems and have democratic, like Jyothsna used the word democratic systems. So not only science institutions should be democratic, all institutions, including community, society, family, need to be democratic, as I think she also hinted. So that way, women can be equal participants in the movements as well. Right now, it's not. I don't think they are not equal participants because they don't subscribe to the views. It's that they probably face discriminatory expectations, and that is why they are not equal partners in the scientific or rationalist movements. So I would say that at least, I mean, of course, we need to address the overall gender inequity problem in society, and all of us have a duty to do that and to participate in that. But I think there is an extra responsibility, for example, on scientists who work in science institutions, and also on people who call themselves rationalists or scientific thinking people, to change their own ecosystems and make them more democratic.
Yeah. Professor Garu, I want to add one thing. I think I'm not sure if women are more irrational or a burden. Certainly, the patriarchy inhibits them to vocally talk about rationalism or anything, right? But I think. I mean, at least in my experience, I have seen even women who are illiterate have more common sense. Actually, they know how to solve their problems. They know how to be vocal about it. They know how to stand for their families. They know how to fight for their rights, and they have done it through ages. So it might be unfair to say that women are not rational.
No. Definitely, I'm not saying that they're not rational. I'm talking.
Right.
I'm talking about the same, cultural pressures that that were put on hampers them to come out and talk.
Exactly. Yeah.
So they are
Yeah.
expected to do
You are
certain.
You are right. You are very right in your point, saying that there are these undue burdens on them for being vocal about their opinions. But I think together, collectively, collectively, we can bridge that gap and we can remove those burdens.
Also, I think, Jyothsna, you brought up a really important point about literacy and education, because in India, although in the US this may not be true, I don't know.
Right.
In India, education actually lands up with more regressive thinking, formal education in India, especially science and engineering education. And it was so evident to me when the annular eclipse happened in 2010. When I went to Kanyakumari, because that's where it was going to be totality. My family didn't accompany me, so they were back here in Bengaluru, and Bengaluru just shut down. And I've seen that many times. Every eclipse, the city just shuts down. Literally, you won't see a single soul on the
Even on the
street.
roads.
And Bangalore is a very highly educated. It's the Silicon Plateau of India, right? The number of people, the fraction of people with tertiary education in Bangalore is going to be very, very high. Whereas when I went to Kanyakumari, it was an eclipse that happened around noon, so it was daytime. Everybody was out watching. All the hotel staff in the hotel I was staying, and everybody was out. It was actually Ayyappa season, so there were a very, very large number of Ayyappa devotees who were about, and I think they had come to Kanyakumari to the Vivekananda Memorial and so on. They were all out. I mean, everybody was out. All the small traders, the shops, the the working staff. Everyone was working. This was something that lasted, a couple of hours. So, there was a lot of time for people to spread the information, saying, "Hey, there's something happening here. Come out and see it," kind of thing. And so all the people were out. And these were clearly not people with a whole lot of education and engineering degrees and whatnot.
Right.
Whereas in Bangalore, it's the opposite. And even in 2020, there was an annual solar eclipse where it was partial, but I mean, the crescent sun is such an unusual sight. And
natural wonder.
But people were watching it on TV. And people were live streaming some, big procedure in some temple or whatever to do whatever. But they would not come out and watch it. And they would not let their women come out and I mean, they would sort of prevent women from coming out and watching it. I mean, all you needed to do was to go on the terrace. And look at it through sunglasses. Those special protection glasses were available everywhere very cheaply. It was hardly a problem. I went to Lal Bagh because Lal Bagh is a very nice spot from which to watch the sky. And we were literally 10 people on the rock in Lal Bagh. So, yeah. So there is that thing. I think India is a little unique. That highly educated people also do not subscribe to scientific thinking. It is even worse than that. Scientists with PhDs who are scientists in the most elite institutions, which are in actually Bengaluru, like the Indian Institute of Science, also don't subscribe to the scientific thinking as a way of life. So it's a real problem. So it's not about common people or
Right. I can certainly relate to that, Prajval, because I was running a math institute here at Chicago locally, and the instructor who I hired has a PhD in mathematics. And if you remember, a few years back, we had a total solar eclipse, I believe, in the year of 2017 or so. So she objected, or she didn't want to come to the institute on that day because she was pregnant and her family did not want her to come, right? So while we are at this topic, Prajval, I certainly want to bring this topic because starting from Babylonians, the Hipparchus, and the great Indian astronomer, right, Aryabhatta, all these people with their ever curious minds, they made a lot of observations, and they were able to understand, predict, and also enjoy eclipses, right? But we know many scientists, especially Einstein, Eddington, they use the occurrence of these eclipses to prove the theory of general relativity, right? History has always proved that many times that this scientific phenomenon of eclipse, but yet people don't understand it, right? And they weave many scary stories around it. They shut themselves inside the homes. As you said, we see streets empty on those days, right? They throw away food. They're thinking that it is impure, right? And I was reading about this superstition where children are buried in pits. They cover them up until their neck, thinking that and exposing them to the sun during that time, thinking that they get relieved of their disabilities, right? All these, I mean, it's scary to think on one end, this natural wonder, this spectacular event that it is we get it in lifetime. I think I drove miles to see that event, and I took my family along with it. We spoke to teachers. We had events conducted by school, many schools, right? We used all our stadiums to have this to have the event at a make it at a grand scale and enjoy it, celebrate it, right? But at the same time, how do we draw this contrast between scientists studying eclipse and using eclipse to make it to take it as an opportunity, right? And at the same time, these scary stories and is there any, do you see any relation of these natural wonders causing any danger to human beings? How do we as science communicators combat this challenge?
Well, in India, I can speak for India because
Sure, sure.
I don't know exactly. I think in the US, the problem is not as severe as it is in India.
The reason I bring this up is because now we are all immigrants in all countries. We come here, we enjoy the advancements of science, but we carry these baggages along with us. The
That is
problem,
true. That is true. Because when I
and
was
we,
on a sabbatical in Stanford, there was a
mm,
partial eclipse there,
mm,
and
mm,
I kind of I went around the neighborhood trying to sort of get people out of their
mhm,
homes to see this beautiful, the
mm.
crescent sun through
Right, right.
the images through the leaves, the pinhole
uh,
cameras
Yeah,
effect through
yeah.
the leaves of trees. It creates this sort of array of crescent suns on your wall and all that. So it was fantastic. So I was
Right.
sort of trying to knock on doors in my
It's a
neighborhood.
lifetime opportunity.
Yeah. And there was an Indian family, and they were nowhere to be seen. And then later
Mm.
on, they told me, no, we thought we won't take a chance. And I
Ah,
was
see.
like,
Yeah, that's the
so,
whole point. That's the reason
yeah,
why I
so
bring this.
how we combat, yeah. So how we combat it, it's a difficult one. I think one thing is that scientists need to be more vocal. I don't
Mm,
find scientists being very vocal about it. In fact, one of my rationalist friends who lives in the city of Mangalore on the coast, and who's a
mm,
very vocal. He was a biophysics, no, sorry, biochemistry professor until recently, but now he just does full time sort of communication about debunking
Are you
some.
talking about Narendranath?
Yes, yes. He claims that he has this thing that it's the silence of the scientists,
Yeah.
which is at the root of it. I kind of agree.
Mm,
It is very frustrating. I agree with
mm,
that as well because I get called to the TV studio whenever there is some
mm.
incident, and they will also put an astrologer on stage, and it
Exactly.
can be a very insulting experience also because
Mm, mm,
just the way the anchors conduct the
mm.
program,
Yeah.
it can be seen as quite insulting to scientists. I kind of take the position that I don't give a damn about that aspect. I just
Mm,
try to say what I think, but I think it does have a little bit of effect in the sense that when they see somebody like that, they don't they're not over the top. They at least
mm,
sort of
mm.
temper their sort of statements a little bit. So
Yeah.
there needs to be much more of a push. That's like in the now.
Mm,
There needs to be a mandate that scientists um, have to they should at least devote 10% of their time for sharing their science, not just as accomplishments but
mm,
also
mm.
as how do we know what we know. So what
Right.
is the scientific method, what does scientific thinking mean? And therefore, and like one of you I think said earlier, the scientific method is not perfect, but it's the best method we have to understand the natural phenomena around us. And it is the best method, partly because it is self-correcting.
Mm,
Uh, Partly, of course, its successes. I mean, although there are many failures, its successes tell us that there is so much validity in the method, but it is also self-correcting, and that is why it is the best method we have. And so, therefore, and for understanding natural phenomena, that is the only method. Whereas, in a TV studio, they will say, what scientific of the eclipse, or what is the religion of the eclipse? And so I sort of I take a stand on that and say that the goal of religion is each one is entitled to their religious beliefs, and we live in a secular country. The Indian Constitution demands respect for all religious views, which I also share. Although I'm a practicing atheist, I respect an individual's religious views, but the role of religion is to not explain natural phenomena. The role of religion is to explain or understand one's relationship to oneself, to understand why there is, hatred and conflict in the world, and to understand relationships with our fellow human beings. So that is the role of religion. The role of religion is not to explain natural phenomena. And I think scientists need to take a stand on this. And so they need to take a stand that science is not a subject. Science is not just a profession and a livelihood. Science is a way of thinking. And in a sense, it's untenable, I think, that if you are a professional scientist, you would see it as only a profession and not as a way of life. I find that somehow sort of
disconnected, right?
I don't connect with that. So I think there is that problem that within the scientific profession, even though the science and technology policy of 1958 of India articulates that science is the thing of the future, but it's about bringing in scientific thinking in society. It's not simply about creating some rockets, which
exactly not just the technological aspects, but also the cultural aspect of it.
And there's also the problem with our education, that again science
True,
is a
true.
subject. Whereas I think science needs to be not just a subject for children who aspire to become scientists and engineers. It needs to be a way to understand scientific thinking for everyone, whether they aspire to be a dancer or a trader or a politician or a scientist for that matter. It needs to be sort of that is not there right now in the way science is taught in schools. Especially there's not enough emphasis on learning by doing. And there is a tendency for engaging with experiments to go on the back burner, especially because these so-called entrance exams into professional careers are like the holy grail for high schools. So high school students go into this frenzy of needing to prepare for these entrance exams, so because of which experimental work goes into the back, sort of on the back burner. And I think that's problematic in terms of children learning science, because
and to some extent, I think you just brought up a point that the anchors make it difficult, and then the communication aspect of it, right? Every time whenever these eclipses occur, they keep saying that it's a never-ending debate. The debate ended already. And there is no further debate about it.
Exactly.
There was no debate to begin with.
I mean, there are many things we don't know. There are many things which are complicated, but this is the simplest thing that we've understood a long time ago. And of course, then they'll bring up, all these things about, you don't know everything, and how do you, scientists may be scientists, but they don't know everything. So I bring up the example that, if a person's cell phone stops working, they don't know, but no person, regardless of whether they are a vegetable vendor or whoever, no person will go to an astrologer with that defective cell phone. They go to the cell phone shop.
So
True,
now
true.
we see a lot now, like asking right questions but wrong people. Even the social media just for the TRP and other ratings.
Yeah.
Like even when there is no debate, they still invite those people and um,
Yes.
put a fight between them to to gain TRPs. So that's so sad to see. But again, like I think we are way past 1 hour, but I'll say Arjun has a lot of rapid fire questions. But before that, Teja, I think, is waiting with a lot of interesting factual questions for maybe black holes, I believe. So, Teja, can you go ahead with your questions?
Yeah. Yes, sir.
Sorry to keep
Uh,
you waiting.
it's fine. It's fine. It is a way more interesting. So yeah, maybe more interesting than the black hole questions I got from the audience as well. So first, my question would be about the recent image of the black hole. If this is an image of a black hole that is sitting in the center of the galaxy, so it's quite obvious that its spin axis must be pointing towards us, and we are on the equatorial plane. So how is it that we are able to see the black hole? So that's first question. Yeah.
Yeah, so that's a very interesting question. Of course, we need to clarify that what was seen was not the image of the black hole, as in a black hole itself doesn't emit any light. So, we can't actually image a black hole. And so, if a black hole were floating around in space all by itself, we wouldn't be able to tell. I mean, there is one special technique which is which uses gravitational lensing around a black hole, but that wouldn't. We don't have the capability yet uh, to see that. I mean, what I mean is that if a black hole is in space, then the background light from the stars would get distorted very close to the black hole, and we would see an effect in principle, but in practice we don't have the resolution and also the contrast between the light from the background stars and the darkness of the black hole is very, very low. So we don't have the capacity to see black holes like that. We can't see black holes directly. Here, the advantage, which was an even bigger advantage in the previous similar image of the central black hole in Messier 87, is that there is a lot of stuff right around the black hole, right around the event horizon. In fact, stuff which is eventually going to find itself enter the black hole, which is shining because it is hot, because it is accelerated by the gravitational potential of this central black hole. And so, because it is shining, there is a high contrast between the darkness of the black hole and the surrounding area, which is bright. And also, this black hole being a so-called supermassive black hole, meaning more than 1 million times the mass of the sun. Messier 87 was several billion solar masses. The one in the center of our Milky Way is 4 million solar masses. So the bigger the black hole, the larger its size, and that size is large enough to be accessible by the best, the sharpest telescope we currently have, which is the Event Horizon Telescope, and it has such a sharp vision because it works at millimeter frequencies, and B, because it is an array which is almost planet size. So in other words, it is individual telescopes located at far points on the Earth, which are combined as an interferometer, not just adding the photons that each of these telescopes get, but combining it as an interferometer, which gives us that very, very, very sharp image, the sharpest image ever. And the Milky Way black hole and the Messier 87 black hole have just the right contrast and just the right size to be able to be accessible from these. Now, it is true that it is the black holes almost face on. So there is, however, the scale of the whole Milky Way, and this, if you compare that with the scale of this central black hole, even though we say it's a supermassive black hole, 4 million times the mass of the sun, and therefore it's very big, it is indeed very, very big. But compared to the size of the galaxy, it's really, really tiny. And so therefore it is not even expected that the axis of the large spiral structure that is our Milky Way would be related to the axis of the central black hole. Because a lot of stuff happens when you go all the way from these large scales into these very small scales. It could be, there is some evidence for it even from my own work, that it could be that some of the stars and so on, which are very close to the center, could form a sort of high density ring, which is called the inner Lindblad resonance. And this is seen in galaxies like our Milky Way. Not that we've seen it in the Milky Way, it'd be very hard because of multiple reasons, but we have seen such structures in other galaxies. And it is true that in some cases, the axis of that inner Lindblad resonance does match what we think is the axis of the central black hole accreting system. But in general, there is no connection. I mean, we know a lot of spiral galaxies in our sort of nearby, in the larger scheme of things, universe, which show these giant supermassive black holes, these giant black holes in the center, which are so-called accreting. So there's stuff around them which is swirling around them on its way to plunge into the black hole, which also generate these jets of plasma. So we see those jets of plasma, and so we are able to see whether the axis of those jets is related to the axis of the overall spiral structure. And studies so far suggest that it's not. So the large scale spiral structure could be oriented one way, and the stuff that is accreting around the central giant black hole could be oriented in a completely different way, even in the plane and so on.
Yeah, another question from the audience. Ayush asks, if nothing can escape from a black hole, then won't the whole universe eventually be swallowed up?
Well, yeah, this is a very common question that I get, that because people somehow seem to develop this picture of a black hole that is like a vacuum cleaner which sort of goes around, clearing up stuff. But that's not how black holes are. It is true that space-time is very heavily curved in the very close neighborhood of a black hole. But the example that I give is, for example, our sun. The gravity, the mass of our sun drives the Earth and all the planets in our solar system in elliptical orbits. Of course, the sun also gives us light and all that. Suppose we do a thought experiment that tomorrow the sun were to turn into a black hole, just instantaneously. Of course, that will affect, we won't get any more light. But if you ask the question, what will happen to the gravitational situation? What will happen to the fact that the sun was driving all the planets, including the Earth, in elliptical orbits? There won't be any difference, because that is simply determined by the mass of, in this case, the sun, and the distance between the sun and the Earth. And neither of that would change even if the sun were to turn into a black hole. So gravitationally, there wouldn't be, of course, I mean, when I say thought experiment, I mean, look at the sun today and then look at the sun tomorrow when it suddenly turns into a black hole. I'm saying, I'm not looking into what happens in the process of the sun becoming a black hole, because then, there would be the whole thing about the space-time ripples and all that. I'm not getting into that. But suppose you just compare these two situations, that the sun at the center of the solar system, and at the same solar system, the same mass as the sun, but instead it's a black hole. Gravitationally, it would be the same for the Earth. The difference would be if you approached very, very close. So something becoming a black hole doesn't mean, of course, there will be collisions, there will be coalescence of black holes. So if you have a black hole somewhere, eventually it could well be that another black hole will come along, or another galaxy will come near it. If another galaxy comes near it, the stars may get, some of the stars, not all the stars, some of the stars may get surrounded, may end up swirling around and plunging into the black hole. But it's not like it's a vacuum cleaner that will clean up everything.
Yeah, I will end with one last question from my side is I would like to take your opinion on what do you think happens to the matter which falls into the black hole?
Oh, I'm not the expert on that. I don't work on what happens after the event horizon is crossed. It's a speculative question. There are people who speculate on this. There's some very nice visualizations of that, of these ideas by, for example, Andrew Hamilton on the University of Colorado Boulder in that department. So they have a website, and some of his work is on there, but it's speculative. And yeah, so I wouldn't, I don't have expertise to speculate on what happens.
Sure. Thank you, Professor. And now Arjun has few questions, few rapid fire questions, I believe. So yeah, you can go ahead, bro.
I
Yeah,
only
thank
wish
you so much.
Prajwal, I only wish every student has a teacher like you.
Yeah.
The way you explained your body language and all that, right? It's so good to see students under your guidance flourish.
Absolutely. And I think in a way, with your Twitter feed and your YouTube channel, you're creating students all over. So we're very grateful. Yeah, and it's great for me to be here because I'm, like I said, I'm the least qualified person on this panel, and the questions I'm about to ask you will prove that. So I thought the black hole was like a vacuum cleaner, so that's something new for me. So I definitely got my money's worth today. So I'll ask one serious question, Prajwal, and then I'll go to some rapid fire questions. So my serious question is, you're really active on Twitter, and from what I can see, you advocate free speech, rational dialogue, scientific temperament. You know, you have all the dangerous habits one could possess in the current environment. So you've even criticized India for its rejection of the WHO COVID toll. So my question is two parts. How worried are you about your own security as a free-spirited academic who voices opinions publicly? And B, how worried should we all be about the future of free speech and scientific temperament in India?
Yeah, I mean, I haven't thought about the first part. I mean, I'm assuming my country is still a democracy, and the constitution will be upheld. It is true that I think we've all been slacking off as far as our constitution is concerned, and we do need to wake up and realize that each citizen's responsibility to actually uphold the Constitution. We do have a really fantastic Constitution, which even though we adapted it in 1950, it was like the product of many decades of the national struggle and everything, and it encapsulates a whole bunch of very very forward-looking points, including the idea that it is the duty of every citizen to propagate scientific thinking, and that is also in our constitution. Yeah, this idea of free speech. I mean, our constitution upholds free speech. There's no question about that. Within scientific institutions, because virtually all scientific institutions in India are funded by the government, there is sometimes a tendency to invoke some sort of government service rules to clamp down on free speech within science institutions. And I think this is a problem. And I think that in order for science to flourish within the country, there's a lot of talk about being a knowledge society, not being, but working towards becoming a knowledge society, and all of this. There's a lot of talk about all of this. For that, a necessary condition is that scientific thinking be a widely imbibed idea among the population, not just among scientists. And therefore, disagreement is a sort of part of it. It has to be, a really a very integral part of science dialogue. It is antithetical to the idea of science to not allow disagreement. So it has to be a very clear separation that an individual has the freedom of speech and can express opinions on anything as guaranteed by our constitution. And the fact that that individual works for some institution should not matter, because it should just be made clear that the views are the views of the individual and the personal.
That's right.
Don't reflect the views of the institution. It's very, very simple.
Yeah.
This is regardless of whether the person works for IBM or the Department of Science and Technology or whichever institution there is. So this is, I mean, it's really a very simple but a core idea that an individual's opinions are personal.
Yep.
Individual can hold personal opinions, and they do not reflect those of the institution. But the other side of it is that if these so-called some government service rules or whatever are invoked to gag personal expression of scientists, that will actually affect scientific productivity. It will actually affect
Yeah.
scientific climate, both within the institutions and outside it. And therefore, it will come in the way of our becoming a knowledge society. So we can't talk about being a knowledge society if we don't foster disagreement and learning to live together with disagreement.
Yeah, yeah, and I think that's the key, isn't it? Living together with disagreement. Yeah, so thank you so much for clarifying that. I've got a bunch of rapid fire questions now. So my first question is, what is your most anticipated discovery in astronomy?
You mean future?
In the future, yes.
Oh, I would say gravitational waves from coalescence of supermassive black holes with LISA.
Right. Awesome. I will Google that after this meeting. Second question. What's your first reaction when an astrologer says our ancestors knew everything and science will eventually catch up to us? It's just not there yet.
Oh, rubbish. Sorry, but
That's good. This is what we want. Awesome. It happens a lot more often in social media, that's for sure. The next one is, if you could have a 1-hour conversation with anyone from history, alive or dead, who would that be and why?
oh, wow, that's a tough one. Neither, I think.
Sorry?
So Emmy Noether was a sort of mathematical physicist. Mathematicians will call her a mathematician, and I think some physicists might call her a physicist, who saw the connection between general properties of symmetry and these very basic conservation laws that we talk about in physics.
Right.
So the conservation of energy, conservation of momentum. And it just blew my mind away when I first came across that.
Wow.
And so, yeah, I would, I think, like to know how she came about thinking about this and concluding.
Nice. Next one is, what is the greatest achievement of humanity, in your opinion, in your lifetime?
Ooh, these are really tough questions. In my lifetime, yeah, I have to admit, I don't like these sort of competitive questions, like what are the best,
Of course.
the
Yes.
I have trouble, grappling with
Well,
that.
I'll change the question to, what is one of the
Well,
greatest
maybe I would
achievements?
say maybe vaccinations.
Awesome. That's a good one. Yes. I've just got two more left. So the next one is, what is the one problem on the planet you would eradicate instantly if you could?
Inequity.
Awesome. That's brilliant. And the last one is a personal question for me. So I'm trying to raise a 4-year-old and a 2-month-old as rationally as possible. So we had a scenario. Oh, thank you. So we had a scenario about a year ago when I was picking up our 3-year-old from the daycare, and we always get out of daycare and we look at the sky to see if the moon's there, because he loves to point out the moon. So it was normal for us. We did it. And then I put him in the car. I took him home. And then when we got home, he sees the moon again. And this time he said to me, it's not the same moon. It's a different moon, because the moon we saw at daycare is the daycare moon. And this is a different moon. And so I struggled so much to explain to him that it was the same moon. So how would you deal with this situation?
Wow, I mean, that's like amazing. I know another close friend of mine who he's also a fellow rationalist and people science movement activist. He's the president, in fact, right now of our network. He also said that when he was a child, he was fascinated by this
Right.
idea. So I think I would try to point out a tree, which is far away.
Mhm.
And have the child move a little bit, maybe from one end of the garden to another end.
Yep.
And, say that you have to turn a little bit in order to like see the same tree.
Yeah.
But the neighbor also sees that same tree, maybe. I don't know, maybe that's
Right.
a way to sort of then say that the moon is really far away and that.
Yeah. So use the tree as a placeholder for the idea, and
Yeah,
then
maybe.
replace
I mean,
the
I don't know.
idea
I had to
with the
think
moon.
about
Yeah.
that a bit more.
Is
Yeah.
he asking the same question on the same day, different times, Arjun?
No, it took about 15 minutes to bring him home from the daycare, but he's convinced it's not the same moon because it's in a different setting for him. So he actually thinks they're two different
It is the
moons.
background and the other things that
And also maybe you could have him keep staring at
yeah.
the moon all the way.
The whole way. Yeah,
whole
it's a good
way.
idea. I
Then the
need to
next question
invest in a.
he'll ask is, why is he following me?
Yeah.
That's true. It's progress of a kind, I suppose, but I'll have to invest in a car with a panoramic sunroof so he can kind of track it as we go home. But I'll try the tree method, and Prajval, I'll get back to you with how I fare with that.
Yeah,
Thank
I
you.
have a suspicion the other method may be a better first step.
Oh yeah, sure.
He's not losing sight of it. Like he's
Okay, it's a good idea. I'll try that too.
Welcome to the world of parenting, Arjun.
Oh, thank you.
Rationalistic parenting.
It's not easy, I tell you. So that's all the questions I had. So I just wanted to thank you for the opportunity for everyone to allow me to
really
speak to Prajval on this.
Very
I
happy.
want to extend Arjun's question on astrology, Prajval. So we understand astrology as a myth, right? But we have to accept that the business of astrology is not myth. So as media reports point it out, the spiritual and religious market in India is worth 40 billions. And the horoscope market itself is 10 billion. So the business of astrology rose at a disproportionate level, and it has become one of the biggest income grossers, right? But as human, I mean, we have seen around us, our parents, our relatives, they have a general tendency, and in our friends and at offices too, they have a general tendency to know about the future. They want to know what is the chance of getting a good job, when are we getting married, what is our chance of getting a good proposal, right? Proposal for matches. What is the best time to get married? And whether you make an investment, whether you buy a house, in every aspect of life, we
Whether
are
someone
looking.
is eligible to get married or not. Let me add.
True. And this has become like a day-to-day, in our day-to-day lives. It has become a very important thing for general public to reach out to astrologers to seek these informed. They think these are informed decisions. Now, do you think these are really informed decisions? Because the basic premise of astrology itself is built on the foundation that a relationship exists between these, between the happenings in our world and also the astrophenomena or influence of stars and zodiac signs, right? Is there any truth to the belief that the celestial bodies actually affect our actually affect the aspects of our life?
Absolutely not. And I mean, there's so many people who have debunked this on various levels, whether it is, the sort of ridiculous predictions that come in the newspaper. Everybody, in fact, I think most people actually know that those predictions in the newspaper are not even by an astrologer. I think just the newspaper editor just makes up something and writes it in there. It's so vague that it could apply to anybody, and that is not the mainstay of astrology. I think in India, it's more the practicing individual astrologers and the hold they have both on the media and on individuals and families, and there's the people have gone hoarse repeating the evidence that there is no evidence to support any of this. There is no even a priori argument to support any of it, because if you calculate the gravitational field and so on and so forth, you can always show that it's an untenable argument. The problem, I think, is that the scientists are not vocal enough on this, and they kind of stay clear of these debates, which I think is not right. Um, I mean, I'm not saying that all scientists should sort of bear all the insults and show up in TV studios to debate with astrologer. That's not easy to do. I mean, I myself find it hard to do, but I do it anyway because I think it needs to be done. But
True.
at least be vocal about this. I mean, the thing is that even within science institutions, I think this is the biggest problem.
Yeah.
I remember that within my own institute, the Indian Institute of Astrophysics, when we were planning the International Year of Astronomy and activities for it, and one of the faculty said that one of our big themes should be to debunk astrology and bring the facts about astrology to it. I mean, I have a fellow traveler in the science movement who has a very actually two, three of them have very comprehensive presentation on astrology and its history, and how it converted from just being about astronomical measurements to then being about predicting the future of lives of people, and how that was an imported idea, first of all, and secondly, how it was untenable, and all the rest of that. But when this faculty raised this thing that astrology should be a strong component of our outreach program, there were faculty who actually said, no, but that hurts certain people's sentiments, so we shouldn't do it. And I'm like, but it hurts my sentiments.
As if we don't have any sentiments.
Yeah. So there is a problem. It's a problem within science institutions as well. And I mean, as the years pass, I agree more and more with Narendra Nayak that it is to do with the silence of the scientists.
Thank you, Prajval. And Prasad, you were going. Are you going to take up the next question?
No. I'm just thanking her. So yeah, I think we are way past 1.5 hours. I think a little more than that. So yeah, unless anyone has any more questions, I think it's time for us to
Wrap up.
Yeah, wrap up.
No more questions from me. Thank you so much for the opportunity, Prajval, to connect with this. And yeah, we look forward to working more closely with you towards this battle against pseudoscience.
Pleasure to be here and address all your questions. Yeah, it's not been like a standard science talk, which has been nice.
Yeah. So then, yeah, I think we can wrap it up there. Thank you very much, Prajval Shastri, for it's an honor, for us to have you here today. Talking everything about science and scientific temperament and fighting pseudoscience, and also very interesting factual questions that we get to know from Teja and Arjun as well. So yeah, that's about this episode of Let's Talk Science. So we will all meet with another amazing guest in another episode. Thank you very much, viewers. Thank you.
Thank you very much. Thank you very much, Professor Shastri.
Bye.
Thank you, Jyothsna Garu. Thank you.
Thank you. Thank you, everyone.
Thank you, everyone.